Okay, so this lecture video will be about influence lines for statically determinate structures. Now, by definition, influence diagram shows graphically how the movements of a unit load across a structure influences some functions of a structure such as reactions, shear, moment, forces, and deflections. So basically, influence diagram ang purpose nito is to know the effect of a moving load for these functions. Yung functions na tinutukoy natin is what's the effect of a moving load sa reaction, sa support, sa beam, sa shear, sa moment, forces, and deflection. Now, generally, yung lecture na to will be dealing about the effect of moving loads sa reaction, shear, and moment. Now, to know the effect of moving loads to these functions, we will draw the influence diagram. Okay, so properties of influence diagram. So, for example, ito yung influence diagram, no? Now, for us to compute for the function, say example, the function is the reaction, all you need to do is multiply the load or the moving load to the height of the ordinate on that point. So, for example, ito yung influence diagram ng function R sa right support. So, therefore, itong height na to, this is the reaction if the moving load is at this point. So, I will further elaborate on that sa next examples. So, ito naman kapag multiple moving concentrated loads, just multiply the ordinates nung moving loads times the concentrated load times the load itself. Tapos add nyo lang. Now, kapag uniform load naman, yung uniform load, multiply mo dun sa area. So, that will give you the function. Again, this function is either reaction, shear, or moment. Okay, now, so influence diagram for simply supported beams, because we have two types. We have simply supported and cantilevered beam. For simply supported beam, in this example, what is the influence diagram for reaction at the right support? So, ang right support natin is RB. So, if you will notice, this is in terms of X or variable yung X, again, because moving load yung unit 1. No? So, variable yung X. So, we should use X here. So, compute for the RB in terms of X. Mag-moment kayo sa A. This will give you this equation. Next step, for plotting naman, we have 2 points. X is equal to 0. Tapos, X is equal to L. So, get the value of R based on these 2X. Substitute nyo lang dito. This will give you these values. Yan na, and then plot. Now, for example, yung interpretation nito is, again, this is the influence diagram for the reaction for B alone. So, ibig sabihin, since meron tayong moving load sa beam, kapag nandito pala yung moving load, ang reaction mo sa B is 0. Kapag nandito yung moving load, ito yung reaction mo sa B. Kapag nandito yung moving load, nandito, ito yung reaction mo sa B. So, ganun yung interpretation, no? We are just visualizing kung ano yung nangyayari dun sa reaction sa B caused by the moving load. So, about any point dun sa beam, kung gusto mong malaman, kunyari, andito yung uniform load, ano yung reaction sa B kapag nandito yung uniform load, yung moving load, sorry. Ano yung reaction sa B kapag nandito yung moving load? So, just compute kunin mo lang yung ordinate dito sa influence diagram, multiply mo dun sa load, that will give you the reaction at B kapag nandun yung point. So, ito pala yung influence diagram natin. So, ang purpose niya is you don't need to compute the reaction at B every time at every single point mo. Kasi dadaan nga naman dyan yung load sa entire section. So, hindi mo kailangan i-compute isa-isa. Paano pag nandito yung load and yung reaction sa B? Gagamitin lang natin yung influence diagram. So, all you need to do is draw the influence diagram and you will know kung nasan ba yung location na pinakamalaki yung reaction sa B. So, in this case, the biggest, the location where we have the maximum reaction is directly under the support itself. Now, if you're asked for the influence reaction at the left support, then draw another influence diagram for the left support. Now, for the shear naman, if you'll remember na shear moment diagram, I have, diba, at about any point sa B, meron tayong internal shear and internal moment. Now, ito yung tinutukoy na shear doon. Diba, if you shear at a point, ang point na tinutukoy is point C. So, for example, what is the shear of point C? Diba, pag ikat natin yan dito, may internal shear and may internal moment. Now, since ang question is shear, hindi ko muna ilalagay yung moment. And then, so we will have two segments na may dalawang limit. Unang limit ng isa is ito, 0x to a. Pangalawang limit is ito, ax to l. Now, ganito, kapag 0 to a, ang gagamitin mong FBD is yung right side. Kapag a to l naman, yung left side naman. So, tingnan natin. Pag 0 to a, eto, 0 to a, gamitin natin yung right side. Check natin. Ayun. Tapos yung shear, no, remember, down, up. So, this is the upward shear, V. So, ang V natin is equal to negative x over L. Tapos, substitute natin yung value ng x, 0 and a. So, at x is equal to 0, substitute nyo dyan. At x is equal to a, substitute nyo din dyan. This will give you the values. Ayan na. Then, next is a to x to l, diba? So, again, ito namang left side ng FBD. So, ito yung FBD niya, diba? And then, VC. So, your VC is equal to positive L minus x over L. So, same lang. At x is equal to a, tapos at x is equal to L, substitute nyo lang dyan sa x. Makukuha nyo yung values. Yan. And then, plot. X is equal to 0, VC 0. Tapos, x is equal to a, negative a over L. Tapos, LA over L. Tapos, L is 0. So, ganito yung itsura ng shear diagram. Okay? So, check natin na. Ayan. Now, for the interpretation, same lang nung sa reaction. Ang ibig sabihin nito, ano yung effect ng uniform load sa shear sa point C. So, therefore, if you are asked, ano yun naman yung effect sa shear sa point na to, dun ka naman mag-cut and you will draw another influence diagram. So, since the entire beam, diba, at about any point on the beam, meron kang internal shear and moment. So, magka-cut ka lang at any portion, then magdodraw ka ng influence diagram. Kasi nga, may yung effect ng moving load dun sa portion na yon will change as it comes along this beam. So, yon, another thing to remember, no, the height of these two ordinate will always be equal to 1. So, if for example, this is negative 0.2, this will be 0.8. So, ang sum nila is equal to 1, always yan. Saan ba sila mag-equal to 1? Doon sa point na hinahanap yung shear. Ang sum ng ordinates is equal to 1. Okay, so next naman is For moment at a point, tulad nung sabi ko, pag magka-cut tayo, di ba? We have internal shear and internal moment. Now, similar sa case ng shear, magkakaroon tayo ng dalawang segment. First is 0 to A, or itong left side, 0 to A. And then, for us to get the equation for 0 to A, we will use the FBD of the right side. So, ito na yun. And then, moment, MC. Ito na, L minus A. So, to compute for your MC, diba, we have MC, opposite direction, so positive X over L, times the moment arm, L minus A. Tapos, same lang. At X is equal to 0, tapos at X is equal to A, you will get the value of your MC, which is this 2. Next naman, limit mo is A to L, or ito, A to L. So, we will use the left side. Tapos, yung internal moment, MC. So, MC is equal to, opposite yung direction, positive L minus X over L, times the moment arm A. Tapos, at X is equal to A, tapos at X is equal to L. This will give you the value of your MC. Yan na. And then, plot. Papansin nyo, X is equal to 0, so, tayong line. Papansin nyo yung XA, parehas yung value. So, isa lang siya dito. And then, yung L mo is 0. So, ito yung itsura ng moment diagram at point C. Check natin. Okay. Now, let's have influence diagram naman for a cantilever beam. Now, if you will notice here, ang influence diagram sa reaction A is a rectangle or uniform siya at any point na 1 ang value. Bakit? Because diba sa cantilever beam, isa lang ang support. So, the only reaction that will resist vertical movement is your RA. So, this holds true. Ibig sabihin kasi nito, no, na at any point, kahit nasaan yung moving load nyo, kahit nasan siya, 1 lang ang value ng RA, which is actually true kasi diba, kung ito yung beam mo, andito yung 8 kN na load, ang reaction mo sa fixed support is 8. Pero kung yung 8 mo is nandito sa free end, ang vertical reaction mo is still 8, diba? Kahit saan mo ilagay yung vertical reaction, vertical load, dun sa cantilever beam, it will always be equal to the support because this is the only support that resists the vertical forces present or added to the beam. So, kapag cantilever beam, ganito yung drawing ng influence diagram. Now naman, this is for the reaction, no? Now for the shear, kunyari ito, shear at point B. So, ganito ulit, diba? Now, kapag shear at point B naman, shear at B is 0 when the load is between A to B. So, from A to B, 0 yung load. So, ito wala. And from B to C, free end lang ulit siya. So, ganito lang. Now, ito kasi, di ba, downward yung shear. Now, since you have here RA, walang downward movement na mangyayari, kaya 0 to. And then, ito naman upward, so 1 consistent kasi walang resistance sa free end. So, ganito kapag shear naman siya. Now, kapag moment, now ito, ang pag-compute ng moment is similar lang sa pag-compute nung sa simply supported beam. You still need to divide it into 2 segments. Cut tayo dito sa B, tapos internal moment. Now, first limit is 0 to A. Ito, tapos right side, ito naman yung FBD. Next naman is A to L, left side naman ng FBD, which is ito. Ito naman yung M mo, MB, tapos compute mo lang yung MB. Then after that, na paki-plot, ganyan lang yung value ng x, and then plot yung diagram, which will give you the influence diagram for MB. Okay, so let's have an example. Okay, overhanging beam, 10 meters long, and then na-extend daw siya ng 2 meters sa right support, so this is 10, then extended ng 2 meters. Now, this is subjected to a passage of 5 kilonewton, and then 8 kilonewton, 2 meters apart. Now, this is the moving load. Ano ba example ng moving load? Kunyari, you have a car o vehicle, no? O, tapos, yung rear niya is 8 kilonewton. Ito yung 5. Example lang to, no? You have a vehicle. So, siya yung example. Now, since this is walang nakalagay na fixed lang siya, ibig sabihin interchangeable. Pwedeng mangyari na andito naman yung 5 kilonewton, tapos andito naman yung 8 kilonewton. So, interchangeable yung placement mo ng load kapag ganito. Ang fixed lang dyan is yung 2 meters apart. Kasi for example, kung this is a bridge nga naman, kung dadaan yung sasakyan, pwedeng going to the right siya or going to the left. So, you can interchange the two concentrated loads as long as 2 meters apart sila. Okay, so first, reaction at the left support. So, may individual influence diagram. Second, reaction at the right support. Gawa tayo ng influence diagram. Third, maximum positive shear, 2 meters from the left. Maximum negative shear, 2 meters from the left. So, ito, isang influence diagram lang siya. Kasi shear lang naman, 2 meters from the left. Next, positive moment, 2 meters from the left. So, we will need to draw fourth influence diagram. Okay. So, first, reaction at the left support or your RA. First step, diba, in terms of X, kasi moving load, and then compute for the value of A by doing summation of moment at B. Again, I will no longer explain how to compute for the reaction. Ito na siya, nakuha na natin. And then we have 3 values for your X. X is equal to 0, X is equal to 10, and X is equal to 12. Substitute it here. Makukuha natin yung values and then plot. Now, the question is, what is the maximum positive reaction for left support? So, ang maximum positive is nandito. So, for us to get the maximum positive, of course, ilalagay natin dyan sa 1 yung mas malaking concentrated load, which is the 8. Diba? 8 times 1 is 8. So, mas malaki yung value. Instead of, kung 5 to, edi mas maliit yung value. So, always, kung tinatanong kayo ng maximum, place the bigger value of the concentrated load dun sa highest point ng ordinate ng influence diagram. So, space 2 meters. This will give you your 5 kilonewton. Now, di ba dun sa concept, sa principle ng influence diagram, to get the reaction at A, maximum reaction, P1Y1 plus P2Y2. Now, ang force 1 natin is 8. Ang height niya sa influence diagram is 1. Force 2 natin is 5. Ang height niya is, now how do we get this height? By using similar triangles. This is 10 meters. This triangle is, this is 2 meters. 2 meters, no? So, this is 8 meters. So, similar triangles, now we have 1 is to 10 meters is equal to y, 2 over 8. So, you will get the value of your y. So, makukuha mo yung y2. Then, you will get your maximum reaction at RA. So, ganito na siya. Ayan na. 0.8. So, ang maximum reaction mo sa RA is 12. Now, baka may nagtatanong, bakit ba natin siya kailangan compute? Now, This is an example kasi ng most of the moving loads tsaka yung beam nila is for bridges. Now, for example, magdi-design ka ng beam ng bridge. So, for you to design for the beam of the bridge, you need to know what is the maximum force na i-resist caused by ng moving load na possible na dumaan dun sa bridge. So, in this case, ang maximum reaction pala nung support is 12 kN. So, since you already have this, pwede ka makapag-design ng section ng bridge na kayang i-withstand yung 12 kN load. So, ganun yung concept, no? That's why we are studying this because needed siya kapag nagdi-design tayo. Especially, ang influence diagram, they are for horizontal members, mostly bridges. Okay, now, influence diagram for the right support, similar lang nung left support, no? Now, in this case, RB naman. So, ang gagawin mo, moment ka naman sa A, makukuha mo yung equation ng RB, moment ka sa A. And then, at x is equal to 0, 10, and 12, you will get your RB and then plot. Then, again, place mo yung highest concentrated load sa highest point. Tapos, yung 5, ayan na siya. And then, compute for the reaction. 8 times 1.2, tapos 5 times 1. Ito naman yung maximum reaction sa B caused by the moving load. So, kung mapapansin nyo, mas malaki yung reaction ng B compared sa A. Next naman is the shear. So, maximum positive shear, 2 meters from the left support, so 2 meters. Ulitin ko, diba, we have shear, internal shear. So, ang unang limit natin is 0 to 2 meters. So, 0 to x2. And then, draw the FBD of the right side. Check natin. Right side, yan na. Now, please take note, no? I did not draw the overhang because wala naman siyang loading, so it does not affect the equation. So, pwedeng ito na lang portion na itong i-drawing nyo. So, write down the VC, V, A, B, C, D. VD na lang. Tapos, write the equation. VD is equal to, same direction, negative x over 10. Tapos, substitute the value of x to get the value of shear. Ayan na. Ang dalawa. Next naman, limit is 2 to 12. Tapos, FBD naman ng left side. Tingnan natin. Tapos, diba, pababa yung VC. VD, sorry. C yung ginamit, sorry. So, this should not be C. So, we have 10 minus x over 10. Ayan na. Tapos, substitute natin yung 3 points. We have 2 meters, 10 meters, saka 12. So, we have x is equal to 0, x is equal to 10, and x is equal to 12. Tapos, plot natin sa diagram. We have x is equal to 0, 0, check. X is equal to 2, negative 0.2, check. Tapos, 0.8, tapos 0, tapos negative 0.2. Okay, so this is now the influence diagram for the shear 2 meters from the left support. Now, for the question, what is the maximum positive shear? So, again, ilalagay natin yung 8 dun sa highest point, then yung 5, ratio and proportion for the height, then compute. Now, yung next question, diba? Similar lang, ratio and proportion for this height, tapos load times height, load times height. Next naman, maximum negative shear. So, since this is the loading, ilalagay nyo siya dun sa highest point sa negative, which is just the point 2. So, andito yung 8. 2 meters yung distance, andito yung 5. So, ito yung maximum para sa negative shear. So, compute lang ulit. Nagkataon na 2 meters sila. So, ang y mo sa 5 is 0. So, ang maximum negative shear, again, nasa negative side, is equal to 1.6 kN. Okay, next, maximum moment at C. So, 2 meters from the left support. 2 meters from the left support. So, 2 meters. Again, yung cut natin, may internal moment. Yung limit is 0 to 2 ulit. Ayan. Tapos, draw the FBD on the right side. Napakilagay na din yung moment arm. This is 8 meters. So, 8 meters. Tapos, moment C. So, moment C natin is opposite direction. So, x over 10 times the moment arm, 8. So, ito yung MC. Tapos, kunin natin yung dalawang value ng MC at x is equal to 0 at x is equal to 2. Again, substitute nyo lang sa x, ha. Ito na yung answers. Ayan. And then, we have 2 to 12 ulit. Tapos, kapag 2 to 12, or ito namang side na to, FBD naman ng left. Ayan siya. This is 2 meters. Ito yung MC natin. So, we have MC is equal to 10 minus x over 10 times 2. Tapos, we have 3 values for your x, no? X is equal to 2, nandito sa point na to. X is equal to 10, dito sa point ng reaction sa B. And then, x is equal to 12, point nung free end. Check natin. Ayan. So, these are the values. And then, plot 0. Ayan. Then, we have 1.6 at 2 meters. Tapos, 1.6 pa din. So, remain. And then, x is equal to 10. Sorry about that. MC is equal to 0. So, 0. Then, x is equal to 12, negative 0.4. Now, please remember, yung x na ilalagay natin is where meron tayong concentrated load na magpo-cause ng change. Na, since here kasi meron tayong reaction sa B, so additional point siya, or this will have an effect dun sa influence diagram or sa shear dun sa beam natin. So, after plotting, maximum moment, no? So, of course, dito mo ulit lalagay yung 8, di ba? Tapos, andito naman yung 5. 2 meters. Bakit nandito? Kasi kung dito mo lalagay yung 5 times 0. So, mas maliit. Again, ang hinahanap natin is yung maximum moment or yung may mas mataas yung value. Yun na siya. Ratio and proportion to get your MC. Okay. So, now naman, for the second example, solve the preceding problem, ang magpapalit lang is yung loading. So, instead of the 8 and 5 concentrated loads, we will replace it with a uniform load that is 8 meters in length. Now, if that is the case, meron na tayong influence diagram. Kasi nga, yung influence diagram natin, nakabase sa unit load. So, yung influence diagram natin is similar na siya all throughout. Ang nagpalit lang naman is loading. So, tingnan natin. To produce the maximum reaction at A, ito yung influence diagram for RA. Lalagay lang natin yung distributed load dito sa portion na to. 1 to ratio and proportion. Ito yung height. And then, di ba, to get the reaction at A, kapag uniform load, W times the area. So, ganun lang. So, W10 times the area of the trapezoid. Ito yung area, no? Trapezoid siya. So, compute nyo lang. So, ganun lang, compute nyo yung RA. Next naman, what is the maximum positive shear? So, eto ulit, 8 meters yung length nung uniform load, tapos area, W area, compute nyo. For the moment, same lang, lagay nyo lang yung uniform load, tapos area. So, that's it. W times area lang for a uniformly distributed load na moving load. Next example is if we have a cantilever beam 9 meters long subjected to a passage of 6 and 9 kilonewton meters, 1.5 meters apart, fixed support. Okay, so please change this, no? Leftmost, no, sorry. Leftmost, kasi nasa left yung reaction. What is the maximum reaction at the right support? Maximum shear from the left end. Then what is the maximum moment from the left? So, yung cantilever is mas madali compared to your simply supported beam. Kasi nga, for a cantilever beam, ang influence diagram ng RA will always look like this. Now, since straight siya, at any point, malalagay yung 6 tsaka 9. So, all you need to do is 6 times 1 plus 9 times 1. This will give you your RA, which is equal to 15. Now, next, for the shear, 3 meters from the left end. So, sabihin natin andito. Sabihin natin andito. 3 meters. Diba, ganito, shear. Now, yung point from the support, papunta dun sa point, sabihin natin B, this is 0, diba? Then, from point B, papunta sa free end, it should be equal to 1. So, ganito yung influence diagram. And then, ilagay nyo ulit yung concentrated loads. So, this is your shear at B. So, ganun lang kadali. Madali lang siya pag cantilever beam. Next, kapag moment naman, tulad nung sabi ko, we will use the same method dun sa single supported beam. So, kakat natin. And then, we have a limit 0 x 3 tapos 3 x 9. So, sa 0 to 3 or itong portion na to, right side ang gagamitin, which is this one. So, ang MB mo is 0. Or moment B is 0. Sa 3 to 9 naman is left side. So, ito. Ito naman yung MB. So, computing MB, this will give you, again, kinocompute. Paano ito kinocompute? No, nagsasummation of moment lang tayo dito sa point na to. Hindi ko na kasi siya in-explain because I'm assuming that you already know that. It is computation of internal forces and just equations of equilibrium lang naman. So, yun, we have MB is equal to 3 minus X. So, plotting the diagram. At dito kasi at X is equal to 0, MB is equal to 0, at X is equal to 3, MB is equal to 0 kasi nga 0 siya. Now, here at X is equal to 3, MB is 0, at X is equal to 9, MB is equal to negative 6. Check natin. So, yun. So, this will be your moment diagram. Now, placing the loads will be 9 and 6. Ayan na. Then again, to get this height, ratio and proportion sa two similar triangles is 9 meters. Similar triangles lang will give you your maximum moment at P. Okay, so this is the last example for your influence diagram. Now, I suggest you study this, and then if nalilito kayo dun sa mga internal moment kung paano ba ito nakukuha. Therefore, hindi nyo pa masyadong naintindihan yung concept ng internal shear and internal moment, which was discussed sa shear and moment diagrams. If I remember correctly, andun na lecture yun. So, I highly suggest that you go back to it and understand it first. Because the more na nagmo-move forward kayo sa lesson without understanding first the previous lesson, mas mahihirapan kayo. Okay? So, if you want, para mas mapabilis yung pag-intindi, no? Mas maganda kasi na mag-grasp nyo muna yung basic concept. So, ulitin ko, please understand first yung mga previous lectures because lahat nung na-introduce kong concept tsaka discussion, tsaka lecture, they will just be a part, magiging part na lang sila nung mga saksi, nung mga next lesson natin. So, kumbaga, dadaanan ko na lang sila, hindi ko na sila explain because iba na yung topic natin. Kumbaga, magiging part na lang siya. So, ulitin ko, no? Please study first and then understand yung concepts ng mga previous lectures before jumping into the next lesson para mas madali nyo siyang maintindihan. Again, if you have questions or corrections na nakita or clarifications, just message me. Okay, so this is the end for the influence diagram using your equations. We also have what we call your qualitative influence diagram. Now, I will teach you that also for another lecture discussion. Now, yung qualitative influence diagram, instead of writing these equations, no, we will basically draw the influence diagram just by looking at the beam. So, and then, titingnan lang natin yung beam, tapos madodraw na natin yung influence diagram based sa definition ng reaction, shear, and moment. Okay, so that will be for another lecture. Okay, so that would be all for this lecture. Thank you.